For 12 years, the most feared rating in tornado history had disappeared. Not because tornadoes stopped destroying towns, not because violent storms stopped crossing the plains, and not because people stopped seeing monsters on radar and video, but because, after Moore, Oklahoma in 2013, the official EF5 list went silent. Every year after that, there were tornadoes that looked strong enough. Tornadoes that ripped through homes, tornadoes that threw vehicles, tornadoes that stripped trees and left entire communities wondering the same thing. How was that not an EF5? But again and again, the surveys came back lower. EF3, EF4, high-end EF4, almost EF5, but not enough. For more than a decade, the top of the scale stayed empty. Then, late on the night of June 20th, 2025, a tornado touched down near a small town in southeast North Dakota, Enderlin. It did not strike a famous tornado city. It did not tear through a major suburb. It did not become legendary because of a dramatic daylight video. It came in the dark. It moved across farmland, rural roads, tree lines, and railroad tracks. And at first, the tornado was not rated EF5. It was rated EF3, a violent tornado, a deadly tornado, but not the storm that ended the drought, at least not yet. Because south of Enderlin, in the open fields, the tornado hit something unusual, something heavy, something measurable, something that would force investigators to go back and ask one question: how strong does the wind have to be to throw a train? That question changed everything. The Enderlin tornado stayed on the ground for about 19 minutes. It traveled just over 12 miles. It grew to more than a mile wide. It killed 3 people, and months later, after additional surveys, radar review, engineering analysis, and help from wind damage experts, it was upgraded. EF5. The first EF5 tornado in the United States since 2013, the first in 12 years. And the key piece of evidence was not a house, it was not a school, it was not a shopping center, it was a train. A stopped line of rail cars became the witness. The evening began with a dangerous setup over the northern plains. Warm, unstable air was in place. Strong winds above the ground were creating wind shear. The ingredients needed for rotating thunderstorms were present, and as the day faded into night, storms began to intensify. One supercell moved through southeast North Dakota, tracking toward the Enderlin area. This was not the kind of place most people associate with the most violent tornadoes on Earth. When people think of EF5 tornadoes, they think of Oklahoma, Kansas, Texas, Mississippi, Alabama, Missouri. They think of Moore, Joplin, Jarrell, Smithville, Greensburg, and Hackleburg. But tornadoes do not care about reputation. They follow ingredients. And on this night, the ingredients were in North Dakota. At about 11:02 p.m. Central Daylight Time, the tornado touched down south of Enderlin. At first, the damage was weak. The circulation crossed open country and began moving northeast. But violent tornadoes do not always begin at full strength. They organize, they tighten, they widen, and sometimes, in only a few minutes, they become something completely different. That is what happened near Enderlin. The tornado strengthened as it crossed rural land. It moved through darkness under a storm base that made it difficult to see. At night, a tornado becomes more dangerous. In daylight, you might see the funnel. You might see debris at the ground. You might see the shape of the storm. But at night, the tornado can be almost invisible. It becomes a roar in the dark, a flash of lightning, a power flicker, a wall of wind and rain. Then the sky lights up for 1 second, and you realize the tornado is already there. As the Enderlin tornado moved northeast, it widened and intensified. It crossed fields, it damaged rural structures, it tore through trees, and then it reached the railroad. A freight train was sitting in its path. Train cars are not ordinary debris. A roof can peel away, a barn can collapse, a mobile home can disintegrate, a car can roll. But train cars are different. Even empty tank cars weigh tens of thousands of pounds. Loaded grain cars can be far heavier. They are large steel objects built to carry massive loads across long distances. They are not supposed to move like toys, but in the core of the Enderlin tornado, that is exactly what happened. 33 train cars were derailed. Loaded grain hopper cars were overturned. Tanker cars were lifted from the track. One empty tanker car was thrown about 475 feet, nearly the length of 1.5 football fields. Not pushed a few yards, not rolled beside the track, thrown. The wheels were left near the derailment area. The cars were displaced into the fields. The pattern of damage showed extreme tornadic force. And suddenly, the tornado survey became much more complicated. Because the Enhanced Fujita Scale is not based on what a tornado looks like. It is not based on how frightening the video is. It is not based only on radar. It is based on damage. Surveyors look at what the tornado hit. They look at how that object was built. They look at how completely it failed. And from that damage, they estimate the wind speed. That is why the EF5 drought became so controversial. A tornado can have EF5 winds and never receive an EF5 rating. If the strongest winds pass over empty fields, there may be no damage indicator strong enough to prove it. If the tornado destroys poorly anchored homes, the damage may look catastrophic, but the construction may not support the highest rating. If it hits trees, crops, barns, or rural structures, the evidence may not be enough. So the official rating does not always measure the full tornado. Sometimes it measures the evidence the tornado left behind. And for 12 years, that evidence had never been enough. Enderlin was different. The tornado hit a train, and a train can tell a different kind of story. Investigators knew the approximate weight of the rail cars. They knew where some of them started. They knew where they ended up. They could study the distance they traveled. They could examine how the cars were moved. They could ask how much wind would be required to tip loaded grain cars and loft tanker cars into a field. The answer was extreme. After the first survey, the tornado was rated EF3, with estimated winds around 160 miles per hour. That rating was serious. EF3 tornadoes can destroy homes, toss vehicles, and kill. But the train damage suggested something far stronger. The National Weather Service in Grand Forks continued the investigation. They worked with wind damage experts. They reviewed the radar data. They examined the damage near the Maple River. They looked at the farmstead damage along the path. And they looked closely at the train. The more the original EF3 rating failed to explain what had happened. The winds were not just strong, they were violent. The analysis supported winds greater than 210 miles per hour. That crossed the EF5 threshold. But before the rating was changed, the tornado continued northeast. Near the Maple River, the damage became even more extreme. Trees were snapped, trees were stripped, some were debarked, some were reduced to broken trunks. In the most violent tornadoes, trees stop looking like trees. They become markers of the core. They show where the debris blasted through at incredible speed. They show where the tornado was grinding the landscape. The damage near the river told the same story as the train. This was not just an EF3 tornado. This was a violent, high-end event. Then the tornado struck rural homes and farmsteads. And this is where the story becomes more than science. 3 people were killed. That fact should never be buried under the fascination with the rating. For meteorologists, Enderlin became a landmark case. For engineers, it became an important damage study. For tornado enthusiasts, it ended the EF5 drought. But for the families in the path, it was a night of loss. A normal evening became a disaster. A storm warning became a direct hit. A rural home became the center of one of the most violent tornadoes of the modern era. That is the part no rating can truly measure. The EF scale can estimate wind. It can classify damage. It can mark a point on a map, but it cannot measure what it feels like when the walls disappear around you. It cannot measure the sound. It cannot measure the fear. It cannot measure the silence after the storm passes. The tornado reached a maximum width of about 1.05 miles. A tornado that wide is almost impossible to understand from the ground. A mile-wide tornado does not look like a narrow funnel. It can look like the whole storm is on the ground. At night, it may not look like anything at all. Just darkness, wind, rain, debris, and a roar moving closer. For about 19 minutes, the Enderlin tornado moved through Ransom and Cass counties. It began south of Enderlin. It ended south-southwest of Alice. And in that short time, it created one of the most important tornado rating cases in years. But the final answer did not come right away. That is important. After a major tornado, people want a number immediately. Was it EF3? Was it EF4? Was it EF5? But careful surveys take time, especially when the damage is unusual. The first rating is based on the best information available early in the investigation. Later, as more evidence is collected, the rating can change. And with Enderlin, the evidence demanded a second look. The train damage was too extreme to ignore. The tree damage near the Maple River was too violent to dismiss. The radar data supported a stronger tornado, so the investigation continued. Experts were brought in. The damage was reviewed again. And on October 6, 2025, the National Weather Service announced the upgrade. The the Enderlin tornado was officially rated EF5. Estimated peak winds greater than 210 miles per hour. Path length just over 12 miles. Maximum width just over 1 mile. 3 fatalities. The drought was over. But the importance of Enderlin was not only that it became an EF5, it was how it became an EF5. For years, tornado enthusiasts debated whether violent tornadoes were being underrated. They pointed to storms that looked catastrophic, but failed to receive the highest rating. They argued that the EF scale depends too much on what a tornado happens to hit. And they were partly right. A tornado crossing a city may leave dozens of damage indicators. A tornado crossing rural farmland may leave very few. The same wind can receive a different rating depending on the evidence available. That does not mean every EF4 should be called EF5. It does not mean every dramatic tornado video proves winds over 200 miles per hour. But it does mean the absence of EF5 ratings does not always mean the absence of EF5 winds. Enderlin made that point impossible to ignore. The tornado hit a damage indicator that could be studied in a new way. A large, heavy object moved a known distance. A train car became wind evidence, and because of that evidence, the rating changed. Without the train, the Enderlin tornado might have remained another violent storm in the gray area. Another tornado people argued about online. Another case where the damage looked stronger than the rating. Another possible EF5 lost to the limitations of the scale. Instead, the train forced the second look. It gave investigators something measurable, something physical, something too powerful to ignore. That is why this tornado matters. It is not just another violent storm. It is a reminder that the EF scale is a damage scale. It is a reminder that rural tornadoes can hide their true intensity. It is a reminder that the strongest winds may pass through places where no camera is ready and no city stands in the way. And it is a reminder that science can change when the evidence changes. The Enderlin tornado also changed how people think about North Dakota. This was not Tornado Alley in the traditional imagination. This was not a famous outbreak corridor. This was a small town surrounded by open land, but the atmosphere does not care where people expect the worst tornadoes to happen. If instability, moisture, wind shear, and storm structure come together, the result can be violent, even in places that do not make national weather headlines often, even at night, even in rural North Dakota, and that is one of the most important lessons of this story. The next EF5 does not have to look like the last one. It does not have to hit a major city. It does not have to be filmed from every angle. It does not have to become famous immediately. It may cross a field in darkness. It may strike a rural home. It may hit a railroad. And the only reason history remembers its true strength may be what it leaves behind. The Enderlin tornado left behind twisted rails, overturned cars, damaged trees, destroyed homes, and 3 lives lost. It left behind questions. Then it left behind answers. The answer was in the train. Heavy steel, moved like something weightless. A tanker car carried hundreds of feet. Loaded cars tipped and displaced. Evidence scattered across a North Dakota field. For 12 years, America waited for another EF5 rating. Enderlin did not just receive one. It proved one. And that is what makes this tornado different. The storm was violent. The damage was deadly. The rating was historic. But the proof was unforgettable. A train thrown from the tracks. A small town added to tornado history, and a drought that ended in the dark